When a quadratic function is given in vertex form, the vertex and the line of symmetry can be identified just by looking at the function. If we look at vertex form here, the h gives us the x-coordinate of our vertex, and the k gives us the y-coordinate of our vertex. For example, in this function k of x, which is parentheses x plus 2 squared minus 1, the vertex is given by -2, -1. X equals -2, y equals -1. Again, we're remembering that the h is the opposite of whatever is inside the parentheses. This is accounted for by the fact that our generic vertex form is minus h. So in the case of, for example, -2, x minus -2 becomes x plus 2. The line of symmetry is just given by x equals h. In this case, x equals -2. Again, where that value is the opposite of whatever is inside the parentheses. So in the case of x plus 2, the line of symmetry is x equals -2. X minus -2 becomes x plus 2. So vertex form example, opposite of -5 is 5, and then 3. The line of symmetry would just be x equals 5. In this case, the a does not matter. Opposite of -1, +1, and -2, where the line of symmetry is x equals 1. This should remind you a lot of our absolute value equations, where instead of having parentheses squared, we just had an absolute value sign, and the transformations, vertex, and line of symmetry rules were exactly the same. To find the y-intercept from vertex form, you would need to convert into standard form, because when we have our function in standard form, the y-intercept is just given by that constant. This k value is not the y-intercept, and in order to find the y-intercept from vertex form, you would need to convert from vertex form into, I probably don't have room for that, from vertex form into standard form. This involves multiplication of polynomials. So x plus 2 squared, this is the vertex form equation, is x squared plus 2x plus 2x plus 4, not forgetting to subtract 1. So in standard form, k of x is x squared plus 4x plus 3. Now I can just immediately identify the y-intercept, which is x equals 0, y equals 3. I can see that on my graph here. Same graph from vertex form. My y-intercept is 0, 3. But again, if I'm given my function in vertex form, this constant at the end is not the y-intercept. The y-intercept is given by finding the c value after converting into standard form.